Hello, everybody. This is Chapter 23. We're going to talk about coal today. Bringing down the mountain is the topic of today. And if we look at the hills we have in front of us in these pictures, you can see over here all these different nice mountain tops in this beautiful mountain range here has been lopped off on this particular site in order for us to access what is underneath these mountain tops in the form of something we call coal. And coal is something that the United States, for example, uses a lot of to help us power our country and give us things like electricity. There's a lot of socioeconomic issues surrounded by the process of coal and the use of coal in our economic infrastructure. We're going to look at a few tonight. This one's going to be a little brief, so I hope you enjoy this looking at the idea of how coal can impact our society. So as we look at this idea of coal, we're going to see how coal can play a major role as an energy source not only in the United States, but of that around the world. And also, despite the efforts to reduce the health and environmental risks associated with burning this coal, the impact of the mining operations will continue as long as we need coal or we demand coal as one of our particular forms of energy. And again, remember, in the United States, coal is a huge producer of our energy, especially on the East Coast, where we have the coal-rich seams in West Virginia, in other places, and that are easily transported after mining operations through railroad up and down the eastern seaboard and beyond. So we're going to look at this in a little bit more detail, and specifically how we can actually use coal as an energy source. So hopefully at the end of this unit, you'll be able to understand the importance of coal as a global energy resource and an economic value that they have is placed on the substance itself. What exactly is this idea of coal? Like, literally, what is it? And there's some methods associated with extracting the coal that are extremely time-intensive and resource-intensive, and how it can be used to generate electricity. And then finally, how some of the role of technology plays a role in getting the coal out of the ground, and how we can use technology to help reduce some of the negative impacts associated with coal mining operations, specifically here in the United States. So in this particular case, we're going to look at Appalachia. And if you didn't know, the Appalachian Mountains are thought to be some of actually the oldest mountains in the entire world. A very ancient mountain chain that was basically formed when two separate continents merged together, pushing essentially the east coast of the United States into the west coast, or I should say maybe the Ohio-Mississippi Valley region, and causing an uplift of the Appalachian Mountains, which at one time looked like as tall and as jagged as, say, the Himalayas. However, over millions and millions of years of weathering and erosion, the Appalachian Mountains are now what's known to us as kind of the rolling or the Great Smoky Hills, or if you're in Vermont, the Green Mountains, or the White Mountains of New Hampshire, or even the Appalachian mountainous regions associated with the eastern seaboard, specifically those even as far as New York and all the way down to Alabama and Mississippi, Georgia, northern Georgia. But we're going to look at the heart of this area in West Virginia, and we're going to see how West Virginia is facing this idea of coal as an economic factor in their survivability of their towns and their infrastructure. So this is kind of the idea. The idea is looking at these particular states, West Virginia, Kentucky, Virginia, and Tennessee, and we're going to look at how the mining operations have claimed nearly 1 million acres of forested mountains across those 4 states. Now remember, our previous examples are chapters on forests and forest ecosystems and the benefits of having various forest ecosystems and strategies for forest management. All can seem to go out the door when we think about implementing mining operations that are reclaiming land for not forest generation, but mining operations. Okay, those are the two kind of fundamental genres of study between this chapter and the previous chapter. And there's still a lot more to come, though, as this field of coal develops into a more prominent form of energy in the United States, as we introduce things like clean burning coal operations, and what that means for energy production in the U.S. Okay, it's a very important fossil fuel, and at this stage of the game, I hope you understand what a fossil fuel is. And if you don't, It's basically a fossil fuel is considered a non-renewable carbon-based resource, and it's essentially formed by the lithification and compaction of ancient forests and uber-saturated carbon sequestering organisms such as plants and animals through Carnivorous and periods of the geologic history, compacted over time and turned into carbon-based rock form of something called coal. This coal can then be mined out and used as energy, which means it is a substance from a physics standpoint. It's a substance that has the capacity to do work, and work from the physics standpoint means be able to essentially use it for energy, and energy meaning to be able to essentially cause things to move or change form or that kind of thing. Not like go to work like you and I go to work in the morning. Different type of work as defined by physics. The ability to do work. Okay. So what kind of work does coal do? Well, coal can provide the energy source that can be released and then can be converted into various different through various different processes to be used in the way in which we want. For example, we can use coal to operate heating and cooling operations. We can use coal to fuel our cell phones and power our lamps and laptops, even fuel our cars in the future, and power literally an industry. Okay, the United States uses about 1 billion tons of coal per year, and it assumes about 40% of the electricity worldwide, and 45% of the United States energy comes from coal. So basically, it's a big hunk of black rock-looking stuff. Literally, that you might have think of something called charcoal you put in your grills. It's something of similar nature, although it doesn't look as compact and neat, and is certainly not impregnated with lighter fluid for an easy light. But a pound of coal equals about enough electricity for 10 100-watt light bulbs about for an hour, or an energy efficient refrigerator for about 20 hours. Okay, U.S. family uses about 9,000 pounds per year if you're that regular standard family of 4, although previous chapters have shown these population dynamics may have changed a bit in the United States and around the world. And then we can look at the EROEI, which is the energy, basically your return on investment. How much am I getting out of this in terms of how much do I need to put in? Okay, so for example, if you look at energy return on energy investment, coal is an 8.1, whereas an oil is a 15.1, nuclear 6.1, wind is 20.1. So it has a relatively lower energy return on the energy invested. What does that mean? That means we have to put a fairly significant amount of energy into this paradigm, into this electrical fuel structure system to produce the electricity that we use and need. So how does it all really work? Well, there is the most common method for producing electricity via coal is basically by heating water to produce steam. Okay, so when you have a lot of water and you put energy into that water in the form of a fuel or a flame or something like that, then you can have what's called in a phase shift in that water, where the water basically it changes state. It goes from liquid to a gaseous state. Okay, so when it turns in that gaseous state, the steam radically expands because it's high energy. And so the point is now to make the coal turn the water from liquid water into that steam. Okay, so we need a few things. We need a water source. We need an infrastructure to burn. We need a place to control the expanding steam. We need some way to harvest that steam expansion. And then we need some way to capture that energy and move it somewhere else, or else it would just stay at the power plant, which wouldn't be very useful. Okay, so first the coal is really sent to the furnace. It's mined out of the earth. It's lopped off those mountaintops, or it's dug out of the mines that you saw earlier. It's processed a little bit, crushed up into kind of fairly reasonably sized chunks, and it's sent to a furnace where it literally is dropped into this furnace, mixed with a couple of other chemicals and things to make it burn hotter and faster and things like that. And it basically is producing heat. Okay, it's literally making a huge tea kettle on your stove. And what happens is that heats the water, and the water is heated within the pipe structure inside that boiler. Okay, the pipes are filled with the water, of liquid water. It finally reaches a state of steam. It changes phase shift from liquid water to steam. When does that happen? Well, any of you physical scientists out there will know that at 212 degrees, water will start to boil. Okay, so, or that should be Fahrenheit, I should say, or 100 degrees C. Okay, so if we can raise the water to that temperature, then we're going to produce steam. Now, steam is a little bit different, and don't be misled by this idea of water vapor. Okay, what they're producing literally is the water vapor. Okay, the vapor is the gaseous state of the water. The steam is what you see, the stuff coming out of the tea kettle. Okay, the white stuff that looks like kind of a cloud. Water vapor is invisible. You can't see that. But what you do see is the steam. Well, the steam is then pumped into a highly pressurized system of pipes, and they keep it under pressure so it can be a superheated steam. Okay, and that just means it's very energetic, and it's piped along into a turbine. That turbine is then spun by the steam. Okay, imagine if you put your fingers in front of the tea kettle. Not only would your fingers get real hot and burn, you could feel the force of the steam being forced through that nozzle on the tea kettle and onto your fingers. Or if you put a little piece of paper in front of it, you probably and hopefully can envision that that paper will kind of drift upward if the steam blows on that piece of paper. Well, if you have enough highly pressurized steam that has the ability to create so much force, not on your fingers, but on massive turbines, okay, which are huge pieces of metal gear-looking things inside a metal casing, and it can spin that. If this right here, these parts right here can spin, and what if this inside here is connected to a very, very basic motor, essentially a copper wire that's wrapped around a magnet? Well, the magnet spins inside of a ring of copper wire, I should say, and that particular setup, that arrangement, is the very basic way of creating electric current. You can do this at home. I mean, very simply, you can make this a little model in your kitchen. It's just that these plants use them on a huge scale. Okay, they produce lots and lots and lots and lots of turns and through lots and lots and lots and lots of coils of copper wire, and that will then produce energy that can go in through things like this that are electrical configurations such as transformers and capacitors and things that will manage the electricity for us so it can be kind of dished out, scaled up, powered down, and more used about how we need. For example, there's peak consumption usage when everyone gets home from work. Everyone turns on their lights and gets home from work, and energy, at least in New England or in the United States, goes up at that time. But overnight, everyone goes to bed, so energy usage goes down. So we don't need to flood the electrical grid with excess energy while everybody's sleeping. That would be a waste. So what they do is they use computers and very smart technology to try to manage when the energy and electricity gets transmitted through these wires so that it is more efficient. Because as we move through these wires, we lose a bit of the electrical power in the form of resistance. Okay. So enter the transformer. The transformer is used to ramp up energy voltage before it's being sent out to the grid, and that's because the high voltage will travel further over huge wires. And then we drape these lines over power poles and ultimately into local stations that will then power your home. And this whole thing is called the grid. You probably have heard of the electricity grid. It's sometimes mentioned as the most technologically advanced, largest computerized system in the world is the United States electrical grid, which is also connected to Canada and Mexico. So it's a huge, complex network of energy and electricity systems with all these different types of electrical generation formats. Coal being 45% of that. Okay, renewables about 10% of that right now. Renewables being things like hydroelectric, wind power, solar power, And then you look at nuclear energy, that's got its whole host of issues. You got natural gas, which has its whole host of issues. And you got petroleum, which has its whole host of issues. But 45%, about over, nearly half of the energy in the United States is fueled to our homes through these wires by the use of burning coal. Literally burning coal. So by doing so, though, it has shaped the progress of how we have to move forth as an economic society. It shaped the economies of the United States. It shaped the economies of the world. But it's also brought with it its fair share of minuses, of negatives. Okay? So if you look at the T-chart, on the negative side, it brings health issues. It brings ecosystem issues. It brings pollution issues. Okay? There's all kinds of issues. It brings economic issues, because if a coal mine is employing a town and everybody wants to shut the coal mine down because it's causing too much pollution, and they succeed because the politician, lobbyists won the politician's heart, well, everybody who was working in that mine is now out of a job. And now they can no longer feed their families, so what do? Go on unemployment, try to find a new job. What if they've been mining their whole lives? What if their dad's dad was a miner and that's all their family ever did? Well, these are the big issues surrounded by coal, and this is what you will hopefully be thinking about as you move through this chapter. I already mentioned a little bit about how coal forms over the millions of years. Okay, all this organic debris right down here will eventually die and get buried over with time. Therefore, we have a lot of overlying pressure that's compressing all this old, dead, decaying stuff into this idea of coal. It's formed where the Appalachian Mountains are, and it's extremely valuable to all of us. Okay, so the point now, though, is that we are finally digging in. Imagine this black line as a mine. We're digging into these mines and getting this stuff out, right? And if it takes millions of years to build this stuff, then how are we refurbishing this coal? Well, this is why it's called a non-renewable resource, because we can't just go back in and fast forward a million years to build up more pressure and more heat and more time to cover over organic debris suitable enough to create coal. All right, so this is what's happening. Okay, and what we think about all of these stashes of these coal seams and mines underground, what we're doing is we're accessing what's called coal reserves. Okay, so if you hear the economists or the politicians or people say our coal reserves stock or our coal reserves or something like that in the country are so X, Y, and Z, that's what they're referring to, is this kind of idea of all of this coal contained within the country. All right, and where is that? Well, Appalachia is the biggest concentration in the country, so the East Coast, right? The problem is getting the mine out, getting the stuff out. You can see that all this has to be blown up here. These enormous mining machines take so much fuel to run. I mean, tons and tons of fuel to run. So 1 ton of extracted coal leaves 7 tons of overburden. Okay, so there's your energy return on energy investment. How do we get 7 tons out of the way to get 1 ton worth of coal that's useful? All right, very, very energy intensive, yet the sheer amount of it is so prominent that it is there and we can get it, and it's fairly accessible. Okay, we can lop off mountains, and mining into mountains, although very dangerous, is not exactly as hard as, say, mining for gold, or diamonds or something, which are much more hard to find. You can find massive seams of these coal, as you can see from this illustration around the globe. Okay, so you can go and get it, and so it's apparent. So it's fairly easy for us to get this stuff. Okay, but now the methods of getting all that stuff that's been really, really accessible, kind of on top, now we got to dig deeper. We got to blow up more earth to get it. It's starting to become a little bit more harder. And it's a little bit more intensive to get this coal out of the mines, and then further to go to get the coal to processing plants. Okay, so we're starting to find that the constraints on the coal is having an issue on surrounding towns and the economy and coastal ecology, or sorry, not the coastal, just the ecology around the particular coal seams that we're mining. Okay, so what else? happens. When we remove these mountaintops, you know what happens to the forest quality when we blast off a part of the forest. That ecosystem now becomes fractured. We lose the type of infrastructure that the forest is providing, and we can then no longer have sustainability within our soils. Soil degradation can go down. We can have washout of sediment. Erosion rates can accelerate, causing turbid and very dirty type waters that are flow into rivers, and this water might be contaminated with coal dust and other kinds of acid mine drainage and things that are just now permeating our once clean fish stocks or places we wanted to fish or the fish can go to reproduce, and kind of messing up their quality of life as well. And it's a domino effect, as you know at this point. Everything affects everything else. Okay, as one student once told me, everything is connected. All right. So the surface mining can have these issues. When we strip mine, the overburden is set aside. It's then used to refill that seam that is strip mined and then put back. But of course, that we know that as best job as it could possibly do to refill it and put it back, it never is like it was originally or undisturbed, because we ripped up the root systems and the ecosystem structures that have been in place in that particular tract of land. The subsurface mining that is going on to get some deeper mines is all said and good. It might not rip off the top of the land, but what you're doing is releasing methane that's captured within the rocks. Your acidifying water, toxins can leach from surrounding rocks, and sulfates can produce acid rain drainage. And then you could have cave formation or weakening of overburden and collapsing of sinkholes and taking away from nutrient cycles that are locked up within local food webs and this and that. But if we do the subsurface mining, there's less physical appearance alteration to the to a mountaintop. Literally, we're not taking off the top of a mountain; we're kind of drilling into the mountain. So you're still having the pretty aesthetics of the mountain there. We're just changing it. It also creates jobs, something that they can do that's for talented and a decent economic wage. But of course, it is very, very dangerous. All right. Coming with these ideas of mining is, of course, black lung. This is the number one issue that is always associated with mining. Is years and years and years of these folks down there in the mines or on the surface breathing in that coal dust. It's kind of just like smoking, once you take cigarette smoke into your lungs, you're basically pulling in particulates that are not supposed to be in your lungs and therefore are not healthy for your lungs to have. So the longer you smoke cigarettes, the more of that dust, that stuff in the smoke you're getting into your lungs. Well, the same thing is happening with the miners in the coal mines. Okay, coal dust is leading to things called black lung. And in 2004, there were 703 coal miner deaths from health-related reasons, as compared to 26 from accidental death, say, for example, from mining collapse or equipment malfunction. So there's a huge number, disproportionate amount of number of people getting sick from the operation of mining from things like black lung, and from coal dust. Okay, but explosions and mine collapse are certainly nothing to shake a stick at, because although black lung is a huge leader of deaths associated with coal mining, there's a huge number of miners that die in mining explosions and cave-ins throughout the year, as well as fire. Fire can also be a result of mining operations if they're not carefully done, and we all know that fires can spread. Okay, and toxic fumes, certainly toxic fumes from carbon monoxide poisoning. This is what, I don't know if you're familiar with, but the old school days, they used to bring the canary, bird cage, down into the mine with them before we had methane and CO2 detectors that would beep and warn the miners to get out of the mine if these gas levels got too high. They'd look over. If the bird had died, then the levels of CO2 or methane were too high and they would get out. That's how they would know. Now we have technology that helps us. Okay, so the idea is, what can we do then about this? If we want the coal and we want the energy, which we do, then how do we bring mining to the table? How do we think about it? Well, over time, mining has led to no trespassing signs and blasting of millions of overburden, loss of forests, soil compactions, which could lead to frequent and severe flooding because the ground can't absorb water. That could nearly flood out homes, as you're seeing from this picture here. That can also include the health of not only you, but your family and your farm, if that's your livelihood. Imagine if all of your horses or something, or cows or cattle or goat or chickens died because of a flood. And so you could have a loss of biodiversity, especially in those aquatic systems that become much dirtier based on the mine runoff. Forest biodiversity will become less, therefore decreasing the quality of the forest ecosystem itself, which is then going to decrease the quality that the forest can produce and make for usable resources for us. All right, and increasing of some of the chemicals used in the mining practices, especially for drilling and exploding some of these rock surfaces out. All right. So there's a lot of issues going on around mining. Surface mining brings severe environmental impacts. You can see from this graphic, better off looking at your text. It's a little bit bigger and clearer there. But there are some serious impacts of surface mining and getting that coal out of the ground. We've gone over a few of them, but we can also see that how they're very kind of interconnected. If here's your power station, everything around it will start to become effective. The question is, what do we do about it? We still want all the coal. We still want to use it and get it because we need the electricity. If we don't use the electricity from the coal, what else do we use? That's the question. All right. The question is, can we use renewables? Will renewables literally provide us with enough of the electricity that we need? Coal is there for us, right? But what can we do about it? Can we produce coal operations that's fairly clean? And the idea is, yes, that many people think that there is a process of clean burning coal that can reduce the amount of sulfur, CO2, NOs, radioactive materials or particulates that are entered into the air through different capture and sequester processes in the coal generation, electricity generation process. The problem is, what's the problem? Well, we can certainly implement this technology to help us fix up a lot of this coal and make it a whole lot cleaner, reducing lawsuits and this and that. Okay, the problem is it comes with a cost. All right, it comes with the clean coal technology cost. How much does it cost to put all these things into place to make everything clean? Well, will you be willing to pay 4, 5, 6, 7, or even 8 or 9 times the amount for electricity you have right now? Okay, would you do that? If your electrical bill is $100 a month, if you knew it was going to be clean burning, would you pay $800 a month for your electricity, or would you rather it be $100? That's the difference. Because to put a capture system into place doesn't look very, very expensive, does it? It looks like a big ball of water and solvents, right? It's very expensive because you got to take those solvents and separate it using chemicals and put it into a stripper, which separates CO2 from the solvent, and then you got to process that. And where do you do with the waste? Then you got to sequester all this and put it back into the ground. So now we got to drill more holes into the ground and inject it back in through enormously highly pressurized pipelines. Look, this is not cheap stuff. Okay, if you want to make a good living and you're interested in this, check out the mining program or agricultural and mining program and get into the field. It's big business. It really is. Okay. Well, there's a reclamation also. We can kind of go back and reclaim the land and return that overburden into something that might be useful for us as well. But again, it's not nearly as good as it originally was, but we could use it for other things, right? So these pictures here of just the mining operations show you that it may kind of look pretty, and to me it almost kind of looks like almost like a Grand Canyon type model, almost, But I know it's not that, okay? And I know it used to be a mountainside with a firm and flowing ecosystem with streams and wildlife and no toxins or particulates being released into the sky, right? But it's turned into this. The point is we use it, we demand it, we want it, we need the electricity. Our society needs it because we gotta power our phones and gotta power our laptops and gotta power our TVs so we can watch Monday Night Football or whatever it is. We want the power. So the question comes down to you, to a personal choice. Although coal is one of our most abundant fossil fuels, it has very significant drawbacks. So what about it? What do you think? Do you think we should continue with coal generation despite its effects? Should we try to create clean coal productions, which might triple or octuple the cost and make it super expensive? Should we try to look at other ways to produce electricity? And are they cost effective, and can they produce enough? All right? Or is there a combination of all the above that we could do to try to help our issue out with electricity? If you're really interested, remember, always conduct an energy audit at home or your workplace. Try to unplug or turn off electronics when not in use. Put outside lights on timers and motion detectors. Dry clothes in the sunshine outside. And in fact, you can turn up or down your thermostat a few degrees. It makes a big difference. Not only to you, I always think of it as, hey, it's a money thing for you. Wouldn't you rather save money? I mean, forget for the second saving the planet or whatever that is, or saving the humans, or saving the animals or the cute polar bears. Put all that aside for a second. Wouldn't you want to just save yourself some money? Put some money back in your pockets. And all you got to do is take care of a few couple of things at home, and that will definitely lower some of your bills, and that demand for electricity will go down, and therefore we won't need to produce as much. If you really love this stuff, you can organize a group. Check out what you're doing at your home, your school, your community, and if you really like it, you can head into that whole idea. Yes, here we are again, policy change. You can go look to see what's going on for the legislation. Become a lobbyist. Write to your lobbyists. See what lobbyist people doing to affect this world. Otherwise, that is it for this chapter. I hope you enjoyed. Take a little bit of a second and think about, you're watching your laptop right now. Where do you think that light is coming from? Your batteries? How do your batteries get charged? You plug it into the wall? Where does that come from? I challenge you. Is it coming from coal? You decide. Have a good one.